For section 6.4, we're looking at unwrapping the unit circle. So far in this chapter, we've been using the unit circle whenever we want to find cosine values, sine values, tangent values, but sometimes it's nice to look at the graphs of the different trig functions by themselves. Look at them individually in the xy plane instead of having to pull the values off the unit circle. So to create the graphs, we're literally going to unwrap the unit circle looking at just the cosine values or looking at just the sine values. And I found two really cool animations that I can't show you with this particular app, but they're the two web addresses. I wish you would kind of pause this and go take a look at them because it's just really cool to see how it looks doing it with the animation before we do it by hand. But the next thing is, of course, we're going to do it by hand. So here's our good old unit circle. And I apologize that the N on my sine right there and the S on the cosine, they were floating up in the air for some reason. But anyway, so what we want to do is we want to take the unit circle and let's do the sine values by hand. Okay, so for our horizontal axis, we're going to use the quadrantal angles. Okay, so remember what those are? We start at 0, then we've got pi over 2, pi, 3 pi over 2, and then back to 2 pi. Okay, so those are the ones we're going to use. So this is going to be pi over 2. This is going to be pi. This is going to be 3 pi over 2. And this is going to be 2 pi. Okay, I'm going to go ahead and put it down here as well for when we do the cosine function. Okay, now, so let's do the sine first, right? So remember, we're looking at the y values of the coordinates at the individual angles. So we're basically going around with zeros and ones and negative ones, okay? So when the angle value is 0 radians, the sine value is 0. So the sine function starts here, okay? Or it's a place to start. It's actually a periodic function, but it's going to start right there. Okay, so at pi over 2, the sine value is 1. So I do need to put a scale on my y-axis. So this is going to be 1. And this is going to be negative 1. So at pi over 2, the y value is 1. At pi, the y value is 0, so back down here. At 3 pi over 2, the sine value is negative 1. Oops. And at 2 pi, we're back to 0. Oh, stop that. Okay. So if we connect them, they're going to connect in a nice smooth curve. It looks like this. Put arrows on the ends because it does keep going. But that's one cycle, one period of the sine function. So be careful, watch your directions on your assignments. I think on the written assignments, I've asked for 1 cycle. Sometimes in the homework, it asks for 2, but that's 1 cycle. Okay, and then let's switch colors. Let's do pink. And let's do the cosine function. Okay, so again, we're doing the same angles. This time we're looking at the x, the first coordinate for the points, the cosine value. So when we have 0 radians, the cosine value is 1. So now this one's going to start here. It does not like me trying to make those dots. Okay, at pi over 2, we got 0. At pi, we've got negative 1. Trying to make the dots fast so it'll stop clicking out. At 3 pi over 2, 0. And at 2 pi, we're back to 1. Okay. All right, and again, it's a pretty curve. Hit the dots, like so. Okay. But like I said, look at the animations. Those are much cooler, but that's what the graph basically looks like. All right, so this is the base graph of the sine function, the base graph of the cosine function. These absolutely must be memorized, just like you were supposed to think about all the properties for the exponential and logarithmic functions back in chapter 5. You got to do the same thing for the 6 trig functions in chapter 6. So these are the first 2 that we start with, okay? And so let's look at this. Again, notice my little S's and all were floating, but anyway. Okay, so suppose I give you these 4 graphs and I say, hey, how do you match them with the equations? Okay, what kind of information do you need to know in order to match those 4 graphs with those 4 equations? Think about it for a second. Okay, all right, let's see. I have, information. Okay, so from 6.3, do you remember what the period for the sine function and the cosine function are? For both of them, it's 2 pi. So it's 2 pi for both the sine and the cosine. And what that means to you is that in a period of 0 to 2 pi, you see what the whole entire graph looks like. After you go past that, it starts repeating itself. It's periodic. Okay. All right, so just like we did transformations with the functions back in Math 150, and like we did transformations with the exponential and logarithmic functions, we're going to do the same thing with the sine and cosine functions and the other trig functions. So just like you would expect, the value out in front stretches the graph vertically. Okay, it multiplies the y values by a. We call the a the amplitude. The absolute value of a is the amplitude. If a happens to have a negative value, it flips the graph across the x-axis just like it did with all of your other transformations. Okay. Now, we also have this other, I'm going to switch colors again. Switch to blue. All right, we also have this other new symbol. That's omega, the Greek letter omega. Just like it did with your other transformations, this is the thing that compresses or stretches on the horizontal axis. So that means it's going to mess with the period, right? So how they've written it in the book is they say omega transforms the graph by multiplying the x values by 1 over omega, just exactly like it was with the other transformations. For us, though, what we're going to do, because we want to concentrate on graphing these things, we're going to come down here and we're going to pay close attention to this, right? So the period, if we're going to stretch or compress the function on the x-axis, what we're going to do is we're going to change the period. So most of the time, the quickest thing for us to kind of get our boundaries to get started is to take the period of the function, so here it's 2 pi for both the sine and the cosine, and divide it by omega. Then that gives us sort of if we start at 0, it gives us the value where we know that the cycle is going to stop, and then we can find the values for what were the quadrantal angles in the middle. Okay, so again, it's exactly the same thing that we've done before. It's just different symbols now. They're throwing in the omega because they've got the A doing something else, standing for amplitude. And we're going to see a phi when we get to one of the other sections. And it's just, just using different letters. Okay, so back to your graphs. All right. So where would you start? Let's see. So we haven't done phase shifts yet. So we don't have to worry about the thing being moved left or right. So we could basically look and see the ones that start high, so that don't start at the origin. So the ones that start high, like say this one and this one, they're going to be what? Cosine graphs, right? And the ones that start at 0, 0, those are going to be your sine graphs. So A and D have to be the 2 cosine graphs. So they've got to be 1 and 2. And how are we going to tell the difference? Oh boy. And then B and C have to be 3 and 4. Notice that all of them have the 2. So it means their amplitude is 2. That means they go up, instead of going up to 1 like we did on our base graphs, they go up, they have an amplitude of 2, and they go down to -2. This one's sort of a giveaway. See that right there? That means it's been flipped. It's been flipped upside down across the horizontal axis. That one's got to be C. See how it starts at 0, 0, and then it goes down? That thing's been flipped. That's got to be C. All right, so 3, that's got to be B. All right, now notice I haven't really done, that was sort of process of elimination. All right, but let's start thinking when we look at 1 and 2, now we're going to have to pay attention to the period with these. We got away with it on 3 and 4 because the negative on the outside of the 2 on this fourth one, that kind of helped us out. But for A and D, we're going to have to look at the period. Okay, so I'm going to change colors again. I'll go back to my pink. Okay, so the cosine graph goes from here down. There's one cycle. So the period of that particular function is 4 pi. All right. The period of this, which other one am I looking at? I'm looking at D. The period of this one is 4. Okay. So trying to be sneaky, all right? So notice down here, if you come and look at number 1 and 2, this one has a pi over 2 for omega, and this one has a 1/2 for omega, just to try to make life fun. So remember from the last page, remember we said that the omega, the thing in front of the x that does the compression on the horizontal axis, we take the normal period, so the normal period for the cosine is 2 pi. We divide it by omega to get the new period. Okay. Now you're going to be doing this by hand, so you practice it by hand. So 2 pi divided by pi over 2 is the same thing as 2 pi times 2 over pi. Sorry, that's running over that, which is 4. So this one better be D. Okay. And then just to check, let's do number 2. Okay, normal period again is 2 pi. We divide it by omega. So that's 2 pi divided by 1/2 is times 2 over 1, which is 4 pi, which is what we got for A. So that one's A. I really like these because you have to, they're very close. If you look at all of the equations, they're very close with the numbers. So you have to really know what you're doing to look at them and to be able to figure out which ones are which. Okay. Okay. Now, you're going to need to graph for me. All right. So this is just one of our sort of typical graphs. All right. What I would start with, okay, think in your head, you know, just for the cosine function, we normally have 1, 2, 3, 4. It normally starts here, goes here, goes here, goes here, goes here. All right, so it's going to be that same basic shape. All right, we need to know how high and how low it goes on Y, and we need to know what these units are for the angles. Okay, so start first. Do you remember how I tell how far it goes? Up and down? Right there, the amplitude. Okay. All right, so the amplitude on this is 3. And one thing that you're going to see me do, you're not going to, unless I'm having to graph 2 functions on exactly the same set of axes, I space it so they all look about the same. When I get through drawing this one, it's going to look very much like the base graph on the first page, but my units are all going to be different. I do it that way because a lot of times getting the units is the thing that's confusing. Once I have the units, then I can scale it however I need to compare it to another graph. I can make them all, move them around and make them look like they need to for comparison purposes. But right now, what I need to do is I need to make sure that I get the units on the axes correct. All right, so the next thing I need is I need to get the period. Because the cool thing about the period is it'll tell me where to stop. If I start at 0, it'll tell me where I'm going to finish one cycle. So remember, to get the period of the transformed graph, we take the period of the original graph, we divide it by omega, which is 2, and we get that the period for this particular graph is going to be pi. Okay, so that means it's going to start at 0 radians, 0 pi radians, and it's going to end at pi radians. So I've basically got those. I need those 3 in the middle. Easiest way to do it is to take pi, divide it by 2. Pi divided by 2 is pi over 2. like it's the middle one. Now get this one. Take pi over 2, divide it by 2. That's what? Pi over 2 times 1/2. That's pi over 4. And then to get this one, it's these two added together. So pi over 4 plus pi over 2. That's the same thing as what? Pi over 4 plus 2 pi over 4. Got to get your common denominator. So 3 pi over 4. And let me see if I can erase where I just put that arrow. Okay, there we go. All right, so this is 3 pi over 4. All right, so now I need to sketch in my graph. I'm going to get that off of there too. It'll look like a part of my picture. All right, so starts high, goes here, goes down there, goes there, goes there. I have, whoops. It should come back down like that. There we go. And here, and here, and here, and here, and it continues. Okay. Now again, it looks very much like the cosine graph I drew on the first page. The main thing is that I've changed the scale. Okay, so this would be squished in tighter compared to the base graph. Okay. All right, you want to try another? All right, that's another cosine graph. Let's see. All right, remember how to start? Amplitude is 2. Okay. Need to know where to start and stop. So the period, well, it's 2 pi divided by omega, which is 1/4. So 2 pi divided by 1/4 is 2 pi times 4 over 1, which is 8 pi. Okay, so that's not too bad to divide up, right? So half of 8 pi is 4 pi. Half of 4 pi is 2 pi. And then just to make sure you get the hang of it so that when you do the fractions, 2 pi and 4 pi is 6 pi. And it starts high. Now we'll stop that. And it looks something like that. Okay. Again, if I wanted to compare it to the graph on the other page, this one would be much more stretched out because remember the other one did its whole period before you even got to pi. So this one's much more stretched out than the one before. Okay. What do you guess it would do if I added 1? If I took that same graph and I said plus 1. Okay. Just like your transformations did with all of your other graphs, it's going to do the same thing here. I am going to have to kind of mark off my scale a little bit better now because I need to be able to go up to 3 and I need to get to -1. All right, so this point goes to here. This point goes to here. This one to here. This one to here. And this one to here. It would be much harder to get those x-intercepts or the horizontal intercepts, but it's the same graph, just moved up 1. So that's what that does for you. Okay. All right. So, how about this? Can you do it backwards? Can I give you a picture, a graph of a function, and you give me an equation? It'll get more fun after we've done the horizontal shifts left and right, but since we haven't done that yet, we can look at them and figure out exactly which one's which one's cosine, which one's sine. Okay. So, first one here, I'm thinking it's cosine, right? We've been doing a bunch of cosine graphs, all right? So it's going to look something like y equals something cosine of something x. And we've got to make sure we get the somethings. The amplitude's the period. Excuse me, the amplitude is the number that you see that gives you how high and how low the sine curve, the sine and cosine curves go. So here it goes up to 5 and down to -5. So amplitude is 5. Okay. Now look at this. Let's see. The period, the time before it starts repeating, the period's 8. All right, so we've got to kind of think backwards because we don't need the 8. The 8 doesn't actually go into the equation. What goes into the equation is omega. So remember it was 2 pi over omega is the period. So we need to solve for omega. So let's see. If we multiply both sides by omega, we get 2 pi equals 8 omega. Divide both sides by 8. I'm running out of space. We get 2 pi over 8 is, is omega. So what is that? Pi over 4 is omega. Sorry that I'm going up and down. So right here, we need a pi over 4. Okay, let's do it again. Let's change colors. Let's try green. All right, so this one, it starts at 0, 0. Since we haven't done phase shifts and we've only looked at sine and cosine, this one's going to be a sine function. So y equals something sine of something x. All right. So goes up to 2 and down to 2. And isn't it going backwards from the way our others were doing? This one starts by going down. Okay, so the amplitude is 2, and then it has a minus in front of it because that thing is flipped over. Okay. For the period, notice it takes until you get to 4. Okay. So we're going to do the same thing again. We don't really stick the period into the equation. We need omega. So we know that 2 pi over omega is 4. So doing the same thing that we did before, essentially cross multiplying, we get that omega is 2 pi over 4, which is the same thing as pi over 2. There you go. All right, let's see. Now, I'm going to do another video for the remaining sections, but I did want you to kind of think about it. The graph of the tangent function looks like this. It has the vertical asymptotes. See them here? Why do you guess that is? Okay, go back to your unit circle. Look at pi over 2. What happens when you try to compute the tangent value at pi over 2 and at 3 pi over 2? And at negative pi over 2, and at negative 3 pi over 2. You're trying to divide by 0, right? So that's where you've got your vertical asymptotes, because those are the places where it would be undefined. Okay. There's the cotangent function. Same kind of idea. Notice it's shifted over a little bit because this time to do cotangent, it's undefined at 0 and pi and 2 pi. And we can go around the other way as well. Notice that the period on the tangent and the cotangent function is just pi. We can see what it looks like from 0 to pi. We've got the whole graph. Okay. And then we're also going to do the secant and the cosecant functions. The cool thing about the secant and the cosecant functions is if you can draw the sine and cosine, you got the secant and the cosecant, because you draw basically, like for instance, if you're going to draw the secant function, you start by drawing this cosine function. You put in your asymptotes where the cosine function equals 0 because remember, the secant is the reciprocal of the cosine. You can't have 1 divided by 0, so that's where these asymptotes are coming from. And then you can draw in, the blue pieces are actually the graph of the secant function. And I thought I had the, whoops, I apparently don't have the cosecant function, but same idea for it. I'll show you that in another video. Hope this was helpful.